Hello world, today I'd like to do something a little bit different. Back in around 2008, there was a version of a C++ feature called Concepts that was part of the C++ working draft that was removed. And work has continued on this feature since then, and in 2015, a technical specification was begun to formalize the wording for Concepts in order to gain some more community experience in how usable and learnable concepts are. A couple of weeks ago for the Toronto meeting, it was voted to pull in that technical specification without a few features into the C++20 working draft. What I would like to do today is present concepts as it exists in that technical specification with all those features. And then I would like you to try implementing a replacement for std_min and a replacement for std_for_each using concepts. I can aggregate all that information together and present that data in a paper back for consideration in the upcoming standards meeting this fall. Interested in helping out with this? Without further ado, let's jump in looking at what concepts is in the technical specification. The collection of requirements on a type is called a concept. In C++, we realize that in the language through testing the type against a set of requirements. In order to do that, we have a new feature in the language called the requires clause. Let's consider this example where we have a couple of different structures that represent some type of socket. We'll say a TCP socket and a UDP socket. They both have the same form of a send function that takes a const char star representing a buffer and an int that represents the size. Perhaps we want to create a function that is going to check to see if a given buffer is valid, and if not, it's going to throw a runtime error. Otherwise, it will call send on the given socket. This is all reasonable enough, and we can see that right now it works just fine. Let's make our world a little more interesting where we have a third structure called a file. And the file doesn't have a send, but instead has a write that also takes a const char star and an int representing a buffer and a length, and we'll dump that data to a file instead. We can see here that if we accidentally call put on it, that we get an error of the form that file has no member named send. And that is reasonable. It looks like we didn't really intend to have this put function work on a file because a file is not really a socket. But maybe we would like to have a version of put that is meant to work with things like files. This is the sort of scenario where we might resolve to using spin_a. Spin_a, substitution failure, is not an error, is a way to remove a particular template overload from consideration under certain conditions. It has been exploited over time for a lot of good things, but was never really intended to be used in the manner that has grown up in C++. For consideration, here is one possible way that we could use spin_a to remove put from consideration if your type here does not have a method called send. This is actually using a feature from the library fundamentals technical specification called the detection idiom, or void t, in order to detect whether or not I have this function called send that takes a const char star and an int. So this is actually a little bit cleaner than some solutions you might see out there in the wild, believe it or not. What this allows us to do is we can have one version of put that is enabled if we have a send function, and then I can write a second one that is enabled if I have, say, a write function. So I can make one version work for TCP and UDP socket and another version work for file and whatever other type that I want that also has a write function of that form. This is not the important thing to look at. This is just the basis for understanding where we're going. Let's tear our example back a little bit. What we're going to want to do is to express some requirements on the type much like we might do with spin_a, but we want to do it in a much cleaner way. One of the first features that Concepts adds to the language is the notion of a requires clause. And this is going to be a succinct way to state some requirements on the type. And the way that works is that after our template introducer, we're going to say requires and then something. The intent of that something is that it's going to be a language feature called a concept. But before we get into that, I'm going to show you a sort of ad hoc way of filling in that requirement, which is itself going to look quite odd, I understand, but it's not meant to be a common solution, but it's a fairly decent intro. We get this syntax looking like requires. I don't want you to panic, because what you're actually reading here is a requires clause followed by a requires expression. And yes, they can go together, but they're generally not meant to. To make it a little clearer as to what we have here, let's indent a bit. This thing is a requires expression. And what that is it uses the same keyword as the requires clause, but the requires expression is going to have an optional parameter list and then a mandatory body. And that body can have multiple lines within it. But what is going to happen here is this is going to effectively evaluate to true if all of this stuff in here works for these parameters. What the compiler is going to do is it's going to take an imaginary socket type of the type we're trying this out on. For this instance, a TCP socket, in this instance a UDP socket. It's going to kind of synthesize an instance of it and then test whether or not it can call send with a const char star and an int. If it can, then that's going to be true, and that true is going to be given to the requires clause, which if that is true, then this whole thing will be considered as a viable template option. This changes our error message now for file to saying that the constraints that we've given here are not satisfied with file. It gives us a slightly better error message there and allows us to create another version for file without so much boilerplate code. So now I've created a second option here for put. This one is going to be enabled if the type that I give it has this expression valid. This one will work if send is valid. This one will work if write is valid. If I had a type that had both, then I would get that the overloads are ambiguous, which is really what I want. But again, this isn't really the preferred way to write it. What we want instead is a concept. This is what a concept looks like. It starts off with the same template introducer, and this is going to be a variable concept. So it's going to have the concept keyword followed by bool, always, followed by the identifier for your concept, and then you're going to assign it equal to a requires expression. So this is the same element within the language that we saw before with the requires clause, that requires, yada. And it can do all the same testing that we were doing before. What this gives us is a syntax then that reads, my template requires that socket T is a socket. If that's true, then I'm going to consider this function in my overload set. I can then create a separate concept for whether or not it's a file and give it this naive test of whether or not it has a write function. And then I can have another version of put that requires it is a file. And if that is true, then I am going to consider this for overload resolution all the same as before. When we want to use a requires clause for testing our requirements, this is the preferred syntax to use. But there are two more syntaxes in the Concepts Technical Specification. And let's take a look what those are. The second syntax uses the same concepts that we developed before for the requires clause, but instead of having a requires clause, we just take that concept and we insert it into our template parameter list where we would have otherwise said type name. So instead of saying type name socket T, we say is socket T. And that means that this now becomes a requirement or a constraint on our function, same as we had before with the requires is socket. Likewise, we can do the same for is file. Notice that it builds all the same. This is the third syntax and is called the terse or the natural syntax. Notice that I no longer have a template introducer on my function. There is no template type name T or template is socket T or anything of that form. Instead, instead of having a type listed here in my function's parameter list, I'm going to use the concept ID. And that means that put should work for any type that matches this concept for the first parameter. Likewise, I can then use it the same for put for isFile. The way that this actually works in the language is that it is implemented in terms of templates. Now the intent here is for concepts to look like a natural function, a regular function that you would use in C or C++, but the implementation itself is actually in terms of templates. And what happens here is that this concept ID, isSocket, becomes what is considered a placeholder. And when the compiler sees that placeholder, then it is going to generate a template for this function. And it is going to work the same as everything we have seen before. It's going to use that same template sort of idea where isSocket is the parameter to the template parameter list. Note that there's another object within C++ that is also a placeholder, and that is auto. The intent is that this works very similar to auto, and if you start working with generic lambdas, you'll find that they work mostly exactly the same, but there's an issue to be aware of. Let's strip back our example a little bit and continue to use this terse or natural syntax, except now I'm going to have two parameters to my function. So I'm going to have a concept called hasFoo that is just going to require that the type that is given has a member function called foo that takes no parameters. Now I'm going to have a conceptified function called defrangulate that is going to take two parameters, each of them needing to have the member function foo on them. I'm going to create a couple of different structures, one called bar and one called baz, and they're going to be distinct in types. They're not related in any way, but they both have the same sort of member function called foo. Notice that I can call defrangulate with two instances of bar or two instances of baz, but I cannot mix them. The reason is that the Concepts Technical Specification requires that duplicated concept IDs within a parameter list result in the same type. So, because I am saying hasFoo and hasFoo, is requiring that F1 and F2 ultimately have the same type. Because bar and baz are distinct types, this substitution is not going to work. Here's where we need your help. What I would like you to do is that, having taken the lessons here, and go out and learn some more about concepts if you would like first, but to re-implement stdmin and std4each in terms of concepts, and then to send your results to me so that I can aggregate them together and put a paper together for the committee to consider about how usable these are and how people choose to use this feature. There's a link in the description below to godbolt.org, which allows you to test out a compiler, so you don't actually have to download it or install anything yourself. Instead, you just go to that link, implement your code there, and then you can click the share button to get a new link to that code to then email to me. That will allow me to go and see your implementation separate from everyone else's. I can then take that, anonymize it, and put it into a single repository for people to data mine against all to their heart's content. I will be making this all public, though your name will be anonymized. If you find that you just can't get a solution, please send me that anyways. That is still valuable information for us to understand where people are hitting some pain points, if at all. So I look forward to hearing back from you, and thank you in advance for taking some time to help us out with this feature. I would argue that concepts is a fundamental component of generic programming. To understand concepts best, there is a book that came out in 2009 by Alexander Stepanov and Paul McJones called Elements of Programming. I highly recommend this book, even though the language feature concepts did not go into C++ at the time. Insight that you can gain from this book is just absolutely phenomenal.